yesterday we talked about properties of logs. We're going to do a little more with those today. So let's take a look at our examples. All right, so what we're going to do first is see if we can understand what the value of natural log of e is. So when we're trying to figure out something like this, you might want to set it equal to x. And then switch forms. So what is our base when it's natural log? E. So we get e to the x equals e. So what is x? 1. So what is the value of the natural log of e? 1. So whenever we see natural log of e, we can really think 1. We could substitute in a 1. Does that make sense? So it makes it simple when we have problems like this. The natural log of e to the 35th. We could do this easily without a calculator. Because what can we do with this power? Can it be multiplied out in front? And then what is the value of natural log of e? 1. And what is 35 times 1? 35. So natural log of e to the 35th simplifies to 35. So anytime we have the natural log of e raised to any power, what does it simplify to? 1 times that power. So just the power.
Are you videotaping this?
I am.
We're on camera.
Okay, now let's look at it a little bit differently. Let's say we have e to the natural log of 4. What does that simplify to? So when I'm not sure, I always put in a variable. And then let's switch forms. If we switch forms here, right now we're in exponential form. So what form would I go to? Log form. So it'd be log base e, which you're right. We don't ever write log base e. We write natural log of x is equal to, what is the exponent? ln of 4. Well, do you remember our fourth law of logs that said if we had the exact same log to the exact same base and they were equivalent, the only way they can be equivalent is if this equals this. So x equals 4.
Whoa, that's intense. No, it did the math. It was the math.
All right, so this is 10 to the log of 2. So let's go ahead and say that equal to x. And switch forms. So what would this be when I switch forms? Log base 10 of x equals log of 2. Now this one doesn't have the base 10 written here. Does this one need the base 10? No, because that's our common log. So we don't have to write base 10. It's not required. It's not needed. So are these in the same base? Yes. What is the only way they can be equivalent? Is if x equals 2. So log 10 to the log of 2 is just equal to 2. Okay, you think you can try this one even though it's a little different? Okay. You try, and if you need some help, I'll do it in just a second. I'll help walk you through it.
Does that mean the banking broke on?
Is that 2 base 2 for the log?
No, it's not base 2. That log has no base written with it. It's 3 times log of 2. Aren't you guys so lucky? Because you get to come and be educated today. And there are many school systems that don't have that opportunity today.
Oh, they're so lucky.
Don't we feel for them?
That makes me feel great.
Wait, why aren't they at
about
school?
myself.
They had school closings.
Because there might be some missing
Weather.
north of
Oh,
Atlanta.
nice.
There might. Well, north of Atlanta there probably is.
From like 8 to 11 today, the airport's on a winter weather advisory.
Okay.
They had a meeting.
You always have the in. I'm going to always
They had
ask
a
you.
meeting last night, and my mom was late, so I made spaghetti for supper
Woo.
and mac and cheese.
What a good daughter.
Wait, I thought we did the house party time.
Okay, what can we do with this 3? It can become an
Yeah.
exponent, so it becomes log of 2 to the 3rd. So what does x equal, guys?
8.
8. 8. Excellent.
That's okay.
Excellent.
That's a candy problem.
This would be closer to a candy problem.
Okay.
That's like a no.
Can we do a candy problem?
That's a no.
That's enough.
That's funny.
I don't think I've ever given a no homework. I think my homework's important.
We should start doing the team test or whatever I was asking last year.
No. I don't think that's
Oh, we used
happening.
But I don't think it's happening whenever
Yeah.
Is our quiz on Tuesday, Miss Willoughby?
Yes.
Learned math in the
Yeah.
last year days.
I won't be.
Okay, so this becomes, if we switch forms, it becomes log base 10. Ooh, I've already used x, so what can I use?
Why? Z.
Oh.
That was weird.
Okay, maybe this isn't the best way to do it then. How can we think about this? Think about exponents. When do I add exponents?
When you're multiplying.
When I'm multiplying like bases, right? So can I rewrite that like that?
Yes.
Mm-hmm.
True. And then you can rewrite 3 log x to log x cubed.
Ooh, so I can rewrite this as to log of x cubed. Okay. Now, what did you notice happened over here? 10 to the log of 2 was 2. 10 to the 3 log of 2 was 2 cubed, 8. What would 10 to the log of x cubed simplify to?
X cubed.
X cubed.
So
What does 10 squared simplify to?
100.
100. So that simplifies to 100x cubed.
I wouldn't have gone. I'm so.
You would have?
No.
I'm
Uh.
confused, like, about how you got the x cubed. Like,
Okay, this 3
This will be cubed.
can become up there and become x cubed. And do you see we showed a pattern? 10 to the log of 2 was 2. 10 to 3 log of 2 was 2 cubed. So this is 10 to the 3 log of x, so it would be x cubed.
so you just like take away the log and the term.
Well, you're not really taking away. This is why it is what it is.
I'll tell you how much fun it is. It's much more fun than writing myself in a slate. Isn't debate team more fun than writing an old
Okay. Let's do a couple more. These are equations. And we're going to take these equations and solve for y in terms of x. So it's going to be y equals something. So how can I simplify this side of the equation?
log yx.
Log yx. How can I simplify this side?
Log 25.
Log of 25. Because it's 5 squared. Okay, so now I got log, same base, and these two things are equal. So what can I do with the yx and the 25?
They have to equal 25.
Yx has to equal 25. So what would we do to solve for y?
Turn x to 0.
Divide by x.
Oh, wait.
Divide by x.
You can do that too.
had already taken the survey?
I took it last year.
Good job.
I thought they did too, but she said, I guess I had you had to choose like 6 careers, and I had like 5, so she said I didn't need to do it. And then that's really
I don't know. I literally did it 7th grade, 8th grade, and 9th grade here. That test. They told me to redo it, and I was like, okay. Yeah, because you have to do that on computer. Yeah. And finance. Yeah, because I have to.
Like, wait, can you get
Not
a
a farmer.
Okay, now let's take a look at this one. If we're going to solve this one for y, right now we have log of y equals 2 minus 5x. What is the understood base here? 10. Okay, so the understood base is 10. So if I were to switch forms, it would become 10 to what? 2 minus 5x. Well, isn't this 10 squared over 10 to the 5x?
Yeah. So that equals
Hate
what?
when they write it like that. Just, it's not right.
Is that as far as you can go, or?
Okay. Or could I write it like this? Is that the same thing? Okay, that's too low for some of you. I see you stretching your necks. There we go.
Oh.
Does that mean the same thing as that?
Yes.
Well, what is 10 squared? 100 times 1 over, what would this be?
10,000 or 100,000.
100,000
Yeah.
to the x equals y. Bless you.
Good job, Peter.
So will we? Will
And
we
that's
not
it.
put 100 over? Never mind.
We could. Now we can't cancel because this 100,000 is raised to the
X.
power, so we can't cancel.
What could we multiply it over and say it's 100 over?
Yeah.
Excuse me?
Okay, my last example for the day is this, and then you get to work. Okay, how can we combine the left side?
X times X minus 2.
Good. Good, go ahead.
X squared plus squared.
When you take a mental break and scribble on your paper, when you look back up, you go, what?
Orange on my paper.
Who fights?
For the mint?
Miss Wilby,
No.
Yes.
my dad just said that the person said she'd call at the end of class. So she'll
Okay.
go down there now. You get it? So she's not going to call me for
Let me finish. All right, so now we can switch forms. So it becomes x squared minus 2x is equal to 2 to the third. So x squared minus 2x minus 8 equals 0.
Oh, 2 to the third.
So x minus 4 times x, what would this be, plus 2
He's saying, oh no.
equals 0. So what are my possible values for x? 4 or negative 2. Now, we always have to look back up at our original equation. Can x have a negative value here? Is there any way to raise 2 to a power and get out a negative number?
No.
No. So that is not part of our solution. Our only solution is x equals 4. And that is today's lesson. So if you will open your books to page 200 and do the problems that are on the board, we're doing 23 through 28 parts B and D only. And then 29 through 34 we're doing all. And on page 202 we're doing 43 through 46. Okay, that's not so bad.
Trevor?
So for 23 through 28, we're only going to do the B, right?